6.3 is more solving trig equations. The difference between this and 6.2 is we are adding in some problems where we might be solving for or involving multiples of angles or half angles, or adjusting solution intervals to have our value x fit in, or theta fit in whatever interval is given to us, okay, or whatever domain is given to us. So here, once again, our theta values are going to be exact solutions. Theta values are going to be in degrees, and x values are going to be exact numeric values, meaning in radians. Okay, so for this one right here, it's going to be in degrees. It's a little bigger. And this one's also going to be in degrees to start with. And then just making notes so I know what form I'm solving in. Okay, so for this one, essentially, the idea is you need to undo whatever is being done to the variable to try and isolate the variable. So the first thing I want to do here, moving from the outside in, is I'm going to divide both sides of the equation by 2. So then I have sine theta equals 1/2, okay? And then to undo the sign, well, I mean, I can answer my question like this, but if I want to look at, like, analytically, what do I write that I'm doing, or what operation am I applying? I am applying an arc sine to both sides of the equation, because arc sine of sine just cancels out and we end up with just a theta. And then we're also taking the arc sine of the other side. So arc sine of 1/2 is the question we're answering. Now, we don't always have to write that, because especially with one like this, we know that we can just say sine of what angle is 1/2 and get our answer that way. But I just want to show you what that actual operation is. Okay, so we ask ourselves, sine in degrees, sine of what angle is 1/2? Remember the order of the question. Sine of what angle is 1/2? Okay, and the answer in degrees is 30 degrees. But we do need to check, because this is anywhere from 0 to 360. So other than in quadrant 1 having 30 degrees right here, where else would we have an angle measure whose sine ratio is 30 degrees? Well, also over here in quadrant 2. And if this is 30, then that means this whole angle. So if the reference angle is 30, that means this whole angle is 150. Okay, and 150 is within this interval from 0 to 360. Now, do we wrap all the way around and say, well, what about 390? Because 390 also has a sine of 1/2. It does, but that's outside this interval. So that's how we know we only need these two. Okay, so for this one, I have 2 sine of 3 theta is equal to 1. Okay, so I'm going to divide both sides by 2. So I'm going to have sine of 3 theta equals 1/2. Okay, now let's talk about where theta can be for a second. If theta can be between 0 and 360, let me write that. Theta is between 0 and 360, then multiplying all 3 sides by 3, I get 3 theta is between 0 and 3 times 360, which is 1080. So I need to figure out all of the values where sine of 3 times theta is 1/2, all the way up to a possibility of 1080. Okay. All right. I'm taking the arc sine, or the sine inverse of both sides here, to undo the sine. And so I get 3 theta. Whoops. Come on, pen. 3 theta is equal to sine inverse of 1/2, which our first reference angle there is 30 degrees. It's positive, so it's in quadrant 1. Okay, let's sketch a little triangle here. So 30 degrees here. We also, though, know, and I'm going to come back to quadrant 2 in a minute, I also know that I could go all the way around and say, well, what if theta is, or what if 3 theta is 390 degrees? Okay, that would also give me a true statement where the sine is 1/2. What if, okay, and I'm going all the way up to something that's restricted by 1080. What if I go all the way around the circle a second time, and now I'm at 360, 720 plus another 30 is 750. 750 is still less than 1080. So 3 theta could be 750 as well. And then the question is, well, can I keep going around a fourth time? No, because then I go above 1080. And so I know I have to stop there. Now, that's only the quadrant 1 options. In quadrant 2, we could be at 150, or, so let me switch colors here. So 150 would be a reference angle of 30 over here. So 150, but then let's say, what if we go all the way around the circle and land over here again? Now we're at 360 plus 150, which is 510. Okay, what if we go all the way around the circle again? Now we're at 870. Okay, I can't go around another time because it gets too big. Now, please notice that I didn't just write a list of angles. I put 3 theta equals that because I'm not actually done solving for theta yet. 3 theta can be any of these things, so I need to figure out what theta could possibly be. Well, let's divide both sides by 3. I get that theta can be 10 degrees. It can be 130 degrees. It can be 250 degrees. It can be 50 degrees. It can be 170 degrees, or it can be 290 degrees. Okay, so that's dividing all 6 of these values by 3. So these are all of the possible values from 0 to 360 where the sine is equal to positive 1/2. Okay? All right, let's do another example here. We have 4 times cosine squared of the quantity x over 2 is equal to 1. So again, I'm undoing what's being done to the variable. So I'm going to start by dividing by 4. Okay, so then we have cosine squared of x over 2 equals 1/4. Now I'm undoing the square. Okay, so I'm taking the square root of both sides to get rid of that. And so now I have cosine of x over 2 is equal to the square root of 1/4, which is plus or minus, don't forget that part, 1 over 2. Square root of 1 is 1, square root of 4 is 2. So now I have that cosine of x over 2 is equal to either positive or negative 1/2. Okay, at this point, I'm going to figure out what is my reference angle that gives me a cosine value of 1/2 in any of the 4 quadrants, because positive or negative, and then I'll figure out what all of those angles are. Okay, so my reference angle is pi over 3. If you need to sketch a triangle, go ahead and do that. So 1 over 2. Okay, so that means that this is 30 degrees, this is 60 degrees, so this is pi over 3. Right here is our reference angle. Okay. So then x over 2, the angle inside here, x over 2 is equal to pi over 3, but the angles that have a reference angle of pi over 3 in any of the 4 quadrants. So pi over 3 in quadrant 1, over here, it would be 2 pi over 3. Okay. Down here in this quadrant, if there's pi over 3 here, that's 4 pi over 3. And then over here, it would be 5 pi over 3. So we have 4 different options for x over 2. Okay? And then x over 2, okay, let's go back and check for a second. X has to be between 0 and 2 pi. Keep moving there. Okay, x has to be between 0 and 2 pi. Well, if x has to be between 0 and 2 pi, then x over 2 has to be between 0 and 1 pi, meaning these two that are bigger than pi are out. Okay, so now we're just looking at these. I'm going to multiply both sides by 2, and I get x equals 2 pi over 3 or 4 pi over 3. Okay, so once again, since x has to be between 0 and 2 pi, then x over 2 has to be between 0 and 1 pi. Okay, which is why we eliminated these two. All right, number 4, again, we are undoing what's being done to the x. So I'm going to add 1. I'm just going to do this, make this a 6, divide by 4 root 3. So then I have cosine of 2x equals 6 divided by 4 root 3, which is going to be 3 over 2 root 3, which is root 3 over 2. Okay. So cosine of 2x is equal to root 3 over 2. All right, so reference angle there to get a cosine ratio of root 3 over 2. That makes this a root 3, and this a 2, so this is a 1. So my reference angle is pi over 6. Okay. Cosine is positive in quadrants 1 and 4. Okay, so I could have pi over 6 up there, or down here this would be 11 pi over 6. So I'm looking at 2x could be pi over 6, or it could be 11 pi over 6. Now, if x has to be between 0 and 2 pi, okay, then that means 2x has to be between what and what? Well, it has to be between 0 and 4 pi. 4 pi with a denominator of 6 would be 24 pi over 6. So I need to look at multiples of these two angles all the way up to 2 full rotations, which is 24 pi over 6, or 4 pi. Okay, so if I take this angle and then go all the way around 2 pi radians, then we end up at, so 12 pi over 6 plus another one, so 13 pi over 6, and then this is 1, if this is pi over 6 right here, so the 1 less than 24 pi over 6 is 23 pi over 6. Okay, and then we divide everything by 2. So we get that x can be, and then so dividing by 2 just doubles my denominators. So I get pi over 12, 11 pi over 12, 13 pi over 12, or 23 pi over 12. And those are my 4 options. Okay, at this point, I would recommend that you stop, pause the video, give these last couple of try, see if you can figure them out. Especially this first one, the number 6 might be a little bit tricky though. Okay, so for number 5, I have tangent of x over 2 on both sides of my equation. I've got, think about it, this is a coefficient of 1, so I have 1 tangent x over 2. And then over here, I've got negative 2 tangent x over 2, so I'm going to add that to both sides for a total of 3 tangent of x over 2. And then that's equal to, I still have a root 3 left over. So again, I'm adding this to both sides of the equation, combining with the 1 tangent x over 2 that's already there for 3. Okay, dividing by 3, I get tangent of x over 2 equals root 3 over 3. And then we need to figure out what is the reference angle where that's true. So tangent of what angle, oh, and we are in, x is in radians here, okay? So tangent of what angle, in degrees, is equal to root 3 over 3, or 1 over root 3. This is the same thing as 1 over root 3, okay? So tangent is opposite over adjacent, so 1 over root 3, right? That makes this pi over 6 again as a reference angle, okay? So x over 2 is equal to pi over 6, or we could be down here in quadrant 3 with a reference angle of pi over 6, so that's 7 pi over 6, okay? Now let's look at the restriction for where x over 2 can be. Well, if x is between 0 and 2 pi, then x over 2 has to be between 0 and 1 pi, meaning we eliminate this, okay? So x over 2 is equal to pi over 6, meaning, let's multiply both sides by 2, x is equal to pi over 3. And then that's my only answer, x, okay? Because this one was too far outside of our interval for x. Okay, last one here. I've got secant of theta over 2 on one side, cosine of theta over 2 on the other side. Remember that secant is equal to 1 over cosine. So this is rewritten. This is 1 over cosine of theta over 2. Remember, flip the ratio upside down, and that's an angle. Don't flip the angle upside down. Okay, is equal to cosine of theta over 2. Now I'm going to multiply both sides of my equation by cosine of theta over 2. So I'm going to get 1 equals cosine squared of theta over 2. Okay, I'm going to undo the square, so I'm taking the square root of both sides of the equation. So I get plus or minus 1, don't forget the plus or minus, equals cosine of theta over 2. And now I'm going to ask myself, cosine of what angle in degrees, cosine of what angle has a value of 1 or negative 1. Okay, so Cosine, remember, is the x coordinate. So we're looking at this point over here or this point over here. This is 1, 0. This is negative 1, 0. So that's at either 0 or 180 degrees. Okay, so theta over 2 equals 0 degrees or 180 degrees. Okay, let's check where the interval where theta can occur. If theta can be between 0 and 360, not including the 360, then theta over 2 has to be between 0 and 180. Is 180 less than or equal to, or yeah, is it less than 180? No, it is not. It's equal to that, so we do not include that. So theta over 2 equals 0 is my only option there. Multiply both sides by 2. Theta equals 0. You do need degrees there, 0 degrees.